So the application of hashing is where? Amazon Fulfillment Center arrangements, or anywhere, like any movie theater seating allocation, or your internal computer science memory allocation, they all involve hashing. And you need to, at least there will be a project. There is no project, I would say, without using hash map or hash table. That's the importance of applying hashing. That's why I always learn hashing through application of real world scenarios like airport, itinerary setup, or anything. And the same you can explain to the interviewer. Let's go back to our other spending concept and quickly see some more such applications. Cool. So now open addressing is another type of collision resolution technique. So here we will be using what? A linear equation sequentially, like AX, like 2x or 1x, just one. So this is very basic. There is a collision between Jock and Andrew. I have created, Jock is the first person. It means fourth row, 10th location is already occupied, but 11th one is free. I just added +1 to that. That +1 is called linear probing. Linearly, I am incrementing. Sir, please take next seat. Next one, there is another collision happens. I will say +1 to that. Sir, please go to 12th seat. That is called linear probing. Now, quadratic probing means, sir, please go to 2 power 1 or any x power 1. Sir, free seats are available to squares. Like go to 2, go to 4, go to 8, go to 16th seat, or go to 30th in this row, 32nd in this row. Like 2, if it is a 2, 2 square, 2 cube, 2 power 4, like that. That's simple it is. Linear means 2 power 0, sorry, 1 power 1, 1, 1, 1, 1, or 2, 2, 2, 2, 2, like that. It will go like a number constant plus 2 that many times. But it is square. Quadratic means square. You can use any linear algebra equation, AX or BX or CX plus D, anything. You can use. The more complex that uniqueness is, that better. Otherwise, that is again depends on the size of the memory and then your collisions clustering. Where the lot of collisions are happening, you should test 100 or 200 times to see collisions, identify the patterns, and then create selection of linear probing or separate chaining or quadratic probing, such techniques. So you need to choose that based on the number of collisions and the such clusters. Okay, these are the things as interviewer I expect from the candidates. I have asked these questions at least 200 to 300 candidates at Amazon alone, not in other companies, just Amazon alone. The reason is everybody go to lead code, solve hundreds of problems, post in LinkedIn and everywhere, and they put in the resume that I'm the top coder. I got, crown. No, that's not the important thing. Do you apply it or not? No. But if I give them a problem, they do the coding really well, but they don't know where to apply. And how to solve also they don't know. Like, why only this AX plus B? They don't know. When to use AX plus B? They don't know. Or AX square plus BX plus C? They don't know. Then why you need? I don't know. I know about lead code, or I did some course from on data structures in the YouTube. Thousands of videos are there. I have gone through and I did it. That's where I want you to be separate from others. Okay? Because in the real world, this knowledge is important to solve real world problems. If you go to Amazon Fulfillment Center and whatever the lead code problem you solve, if you apply that, the fulfillment center storekeepers struggle a lot. Best example is your Daymart. You have barcode allocation, right? You need a unique address to search the element that requires a hashing. Barcode should be always unique. You shouldn't have two stickers for same billing. What happens? customer might pay more money rather than paying to the original product if there is a collision. So that involves hashing and collision resolution. So this hashing solves real world problems. So you should learn it that in that way. And then you should work more than just lead code marks. They will get some rank, right? Hacker rank or lead code.
Mm.
They'll get one or some points. It's not for the points. You need to go more than that and solve complete end-to-end collision resolution by doing 100 to 200 testings to the use case, not just one or two test cases. I have done, I know hashing. It's not like that. Hashing will be forever for next 20, 30 years. It never leaves you. See, algorithms are there for last 100 years. Computer science has come only for last 50 years. After Second World War, technically, 60 years. Computers were invented after the Second World War from onwards, 1945 onwards, mainly. But algorithms exist before that. But they're common sense algorithms. Means we used to do that manually with basic maths. Mathematics were first, and then algorithms. And then computer science has come. Computer science is helping to solve algorithms, but not just to do something and then, saying that I am great, so give me a job. So out of those 200, technically I rejected around 195 candidates. Sorry for all those. But I had no choice because it will be pain to me at the office if I keep training them. I can train like you, right? At office.
Yeah.
I have to take care of 300 plus folks across globe. For my customers, for my internal team, customers, and then the dependent teams. There will be on more than 300 in our division. That's less. If I consider total customers, there are 10,000 plus. So that much work you will have. So, and it deals with 120 plus billions worth money. A small mistake cost you at least millions, not billions. Cool. So that's why don't learn just for interview, learn for real application, real doing the real work. That is important. You can't learn everything from one internship. You should have passion and this kind of intuitiveness right from today. So that job is just outcome of it. You can be owner of your own company or you can do job. Okay. But these guys like Bill Gates, Mark Zuckerberg, they were all like students like you, but they became owners of companies. As a student, they did not complete their university. They are past dropouts because their IQ is like this. They learned this and they started building apps. Even Elon Musk, they started building apps, being students. And then they don't need to find jobs because their apps gave them money. Bill Gates built a DOS operating system, Zuckerberg, Facebook, and it is still alive. And then Musk built PayPal kind of stuff. He developed a PayPal kind of banking app and then sold it to PayPal. I think he built some app and then sold it to PayPal. So that money was enough to start another two companies. Cool. Uh, so any doubts? We might need to take 10-minute break and then I'll send you one more link and take
Sure.
another session for another 7 to 10 minutes for more applications. Applications and yeah, some interview questions too. Okay. So this is what quadratic program probing you have already seen. 2 square, something like that. Ax square plus b. Don't worry about code. Each and every line is clearly explained. You can just go through this and I'll put this under the video description and play with it.
Okay.
Now, yeah, we have 1 more minute, right? Let's see. Double hashing. This was missing, right? Double hashing means you have first hash function, there was a collision, create second hash function and store it on other location. Okay. So if you use hash function A, use the hash function B on top of this address. or that element to store. That's it. So if I want to search for 200, my hash function will return location 3. I will see there is no 200, and I will again ask second hash function, and then it is available here. That's it.
Why do you need 2 hash functions?
That is just a style to create uniqueness. Because
Okay.
first hash function failed to create unique address for these two. 100 and 200 are getting same value, 3. So
Okay.
two users got the same seed. So I need to find another random seed for second user. So I have called another time, another program, another function. This is not working out. So I have called another one. So 200 got 7 this time. You got it? It is
Okay.
like some
Yeah.
random number generation. That's it. Cool. So